Okay, let me give you a quick introduction on extreme learning machine. The extreme learning machine is a very simple machine learning architecture. You here is pretty much a schematic. So the x here's the input x and here's the output y. It goes through a sparsely weighted weight matrix, which is like a randomly weighted, so it is a randomly sparse matrix, usually at 10% or so. It pass through that, so that it does like basically doesn't require any trainable parameter, and then you get a nonlinear activation function, and of course you have random bias. Then you get the intermediate, and then from this output you go through a linear regression, usually as a ridge regression, as a PyRCN, for instance, the package like PyRCN. You got essentially you have a nonlinear function that is randomized and sparse, and then go through linear regression getting an output. Why does it work? In the sense that any neural network can be expressed as this function. Imagine any type of function of input x equals y. This can be generalized to a degree of most of the neural network. The extreme learning machine, ELM, model is essentially, I think it as the nonlinear function. So pretty much this is a bank of a nonlinear function, and you have a linear combination of those nonlinear function plus a bias. So this pretty much give you a best of both world. You have a very little little free parameters that is very unlikely to overfit. So you have a number of you just need a number of data equal number of the dimension of the input. So that's very convenient because for other ones like dimensional input, you will need like at least order of magnitude bigger amount of data to train it. And then it's very fast for inference because it's at ON, because you don't need it's a linear regression with nonlinear functions, and also it can be updated quickly because up until here it does not have any trainable parameter. You just need to update the linear regression bit, so you can use something like a partial fit in SciPy. But caution, since it's very simple, just a linear regression, it is really sensitive on data. So if you have a very unbalanced data, you need to redo balance it. You need to do some little bit more on the feature engineer than the traditional deep learning network. You just hope a complex architecture will do the work for you. And yeah, reading the description, I will put a little bit more information in the description. And thank you for attention.